Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. Here I am in Google Colab, which you can find at colab.research.google.com. And here's where I'm going to begin building our project. All right, so first steps first, we have to upload our CSV file into the project. So we're going to create a new code cell, and we're going to begin by importing the files module from google.colab, because this files module will allow us to upload a file to the Colab. All right, then I'm going to make another variable here. I'll call this my file, and I'm going to use the files module.upload function. When I run this code cell, I am going to get a prompt to select a file from my computer, and then that file is going to be loaded into the Colab project. So hit this button, choose files, and then select the file author and quote. This is a CSV file that I will include for you in this section. Okay, then hit enter or open, and look at that. You'll get this message saving author and quote.csv to author and quote.csv. This means that throughout the whole project, you can now refer to this file by its name, and you'll be able to access it inside of this project. So you see here, 100% done means the file has been 100% uploaded. All right, now we can verify that we do have the file. So we'll make another code cell, and I'm going to call print to print a message to my console here. I'm going to print the length of file.keys. Then I'll run this code cell and I'll get one return. That's the number of keys in the file. I can also just print out the file itself, and look at that. I will get the name of the file, author and quote.csv, and then I'll get all the contents of the file. So we can see here author, comma, quote. We have backslashes and spaces, and we have all the text. Okay, so that verifies that we do have the file there. Next up, let's take this file and let's use the Pandas library to read this CSV file. So we have to decode the CSV file in order to create a list from it. Okay, so I'm going to have to import the Pandas library, so import Pandas. This is a very commonly used library, very popular for data pre-processing. Okay, and the Pandas library has many functions that we're going to put to use, okay? Starting off with the read CSV file. And for that, we call pandas.read_CSV. This is going to allow us to take a CSV file and convert it to a Python list. So in here, I have to grab io.string.io in order to create a string or more out of the CSV file. So for that, I do have to import io as well. So let's just import io in order to access that module as well. Then inside of the function here, string io, we are going to pass in our file and at the author and quote.csv name. All right, because the file, it refers to everything we've uploaded, which is currently just one file. But we could have multiple files in here, so that's why we need to grab everything that's been uploaded and then add the appropriate file name. So really this will be more accurately called directory, but it doesn't matter. Okay, next up, after we have converted the CSV file to a string io, we are then going to add decode in order to decode the characters. And in our case, the character set is UTF-8. This is the most common character set. It's for the English language, for Roman characters. And as well, we have to define a separator, and our separator is a comma. So let's talk about what that separator is. This separator is going to take the CSV file and it's going to create a list out of the CSV file, and it's going to split all of the strings inside of the CSV file. How it splits them is going to be at every single comma. So that's considered the split point. And in fact, I'm just going to open my CSV file for you to show you. Okay, this is the CSV file, and I've included it for you in this section. So it's called author and quote.csv, and I just opened it in my text editor, but you could also open it inside of Excel or inside of Google Sheets, because it is a CSV file after all, but it's very similar to a text file. All it has is author, comma, quote at the top as the header, and then it has an author and also a quote per author, so it has these rows. I created this file inside of Google Sheets, and it's really just two columns, an author column and a quote column. Now, when you create a file in Google Sheets, if you export it and if you open it inside of a text editor, you'll see that every column is going to be separated by a comma. So that's why we use the comma as the separator. There are many other separators, like for example, you could use a space as a separator or a tab as a separator, but the comma is really easy to understand, so that's why I chose that. And the comma was also just automatically created for me. When I created this CSV file in Google Sheets, it then just immediately turned every new column, like every space in between columns, into a comma. Otherwise, how would it be able to separate columns when I open it inside of a text editor? All right, so that is our CSV file. Feel free to look into it more if you're interested in seeing all the authors and quotes. Okay, so now we are using Pandas to read that CSV file. And the result of this function reads CSV. It returns a list, a Python list. And that's because we take this CSV file and we turn it all into a string with string IO. We turn it into one huge string with the appropriate character set, which is just the Roman language or English. And then we have the separator, a comma. So we take that string, the first argument of read CSV, and we separate every single substring inside of that huge string. We separate it at every comma. And those are the two arguments that are required for the read CSV function. The result of this is going to be a list of our authors and our quotes. So for that, I'm just going to save this as my file list. Okay. Now we have a variable file list that we can refer to. So let's use that and verify that we do indeed have everything loaded in. It's my file list, and I'm going to print out my file list.head.toStrings. This will give me the head of it. Don't pass this as a parameter, but instead just assign it to equal that sep argument. Then if I rerun this code cell, look at that. Now I get the first 6 rows in my CSV file. We get the head, and then we get the first 5 entries. And that's what we get when we call this head function and convert it to string. Now this file list, it's more accurately called a data frame. So really, I'm just going to change this name to data frame so we don't get confused. Whenever we use Pandas, we'll often return a data frame. This read CSV file returns what's known as a Pandas data frame. That's why when we try to print it, we have to get its head and then to string. We can't just print out its values. I mean, we could try. You can print out here data frame and run this code cell, and we get a very similar result, but this time we're printing the whole data frame you see here from index 0 to 49. So if we want to just get the first 5 entries, we use .head. I can call print dataframe.head and rerun this code cell, and I get a very similar result here as well, but we use toString just to make sure that none of the quotes get cut off. All right, now how do we take this Pandas data frame and how do we convert it to a Python list? Well, first off, let's look at the data frame with more detail. I'm going to print here the data frame, and I'm going to add the describe function. So every data frame has a lot of Pandas functions that you can use, such as head or describe. And the describe function returns for you some information about the data frame. So first we have the first row in the CSV file, which is author and quote. Then we have count, which is the number of entries. We have unique, which is the number of unique entries. We have top and frequency. And that would be if we had non-unique entries, then we would see the most frequent entry here in top. But because all of our entries are unique, we just get a random value here. So this provides us some more information about the data frame, which means we know that if we create a list, that list should have 50 entries. And if you have any error messages coming up at this point, then it probably means that your CSV file is corrupt. So just make sure whenever you are working with a CSV file that it is in the proper format. For example, here it is in Google Sheets, our same CSV file. And typically it's best to open your CSV files in either Google Sheets or in Excel, some kind of software that is primed or created for working with CSV files. Because even if you just open a CSV file in a text editor, sometimes the formatting of the file can change and then you'll get error messages. So I do recommend when you're working with CSV files, open them in Google Sheets or Excel or another platform that's specific for CSV files. Okay, so if you do get any error messages, just make sure that you only have 2 columns here in this CSV file, because sometimes if you open it in a program, it can accidentally cut some text, perhaps at a space or at a line break or even a text wrap, and it can move it to a 3rd column, which is not what you want. You want to make sure you only have 2 columns. All right. If you get any other messages as well, any other error messages, then just Google them, search them up, or even search them up on Stack Overflow. Typically, you can always find a solution to any error messages that you get. All right, back to our data frame. How do we take this data frame and convert it to a Python list? Well, what we can do is just use the toList function from Pandas. So I'm going to open up another code cell. I'm going to grab our data frame, and at a specific column, at the quote column, I am going to use the toList function to convert that to a list. And then I'll save that as our quotes list. All right. Then I'm going to print out my quotes list. I'll run this code cell and look at that. Now what we get is not this formatted data frame, which kind of looks like it's in columns, but we just get a regular Python array, also known as a Python list. It has the square bracket to open up the list, and then it just has all the entries in quotation marks because they're strings, and every entry is separated by a comma. And this quotes list, it only has the quote column. It doesn't have the author column because we took the data frame and we took the column quote and converted all of its entries to a list. We could do the same for the authors as well if we needed to. And that is how we can load in our CSV file here into Google Colab, into our Python project. We also learned how to use the popular Pandas library to convert our CSV file to a data frame. This is very commonly done for any data science project. And then we took that data frame and we learned how we can create a Python list out of the data frame. All right, join me in the next lecture. We will continue our project and we're going to learn how we can tokenize our text data, how we can turn different words into tokens. And that's very important because we need to be able to represent words numerically if we want to perform any kind of data science or machine learning on it. Join me in the next lecture where we will continue the project. Hello everyone and welcome back to our course. In the previous lecture, we learned how we can load in our CSV data, turn it into a data frame, and also create a list out of that. And we can verify that we've done this properly by printing out the length of our quotes list, because it should have the same number of elements as we have rows, which is 50 different entries. Awesome. Okay, next up, we are going to learn how we can tokenize our words and sentences. All right, so first up, I'm going to create another code cell, and I'm going to open up a loop. I'm going to loop for every index and as well text in an enumeration out of my quotes list. So an enumeration means I'm turning this list into something that I can enumerate through, just go through one by one. And in that way, I can create this for each loop. Okay, and let's start by tokenizing by sentence and then by word. So I'm going to create a variable called tokens, and I'm going to take word.lower. So I am taking each word and I'm going to convert it to lowercase for every sentence in NLTK.sentence tokenize of the text. Okay, let's pause here. NLTK, this is a library specifically for natural language processing. It has this function sent tokenize, which can tokenize a sentence. In this case, it's going to be our text, because in quotes list, we have an index and we also have a text which represents the whole sentence, because after all, the list is just a list of sentences. That's why when we enumerate through the list, each value is going to be a sentence. Now, in order to actually use NLTK, we do have to import it. So let's just make sure at the top of the cell, we are going to import NLTK. All right, next up, that is just handling the sentences. We also have to, as well, handle individual words. So I'm going to add here, for every word in NLTK.word tokenize. So this time I'm using a similar function, but to tokenize a word. And the word is going to be all the words inside of our sentence. All right. Great. This is going to return for us an array of tokens, as you can see. All right. Now let's process all the tokens per quote. So for every token in tokens, we are going to loop through. And what we have to do is we have to clean the data. We have to remove accents and punctuation and then process the part of speech. So let's begin. First, we are going to remove all of the accents from our token. So for that, I'm just going to create here my result variable, and I'm going to call it remove accents on the token. Remove accents, this is going to be a helper function. So let's create that outside of the loop. We're going to define a function called remove accents, and it's going to take in some token. Right? Then we're going to return an empty string joined with x for every x in Unicode data.normalize nkfd and our token. So we're first normalizing our token. If x in string.ascii letters, so that means if x is a string from the ASCII character set, which is the most common character set, or if x is just equal to a space. All right, and that is going to return for us the normalized token, so with the accent removed. Now, you'll notice here we've used several libraries here, Unicode data and also string. So we do have to make sure that we account that we have any kind of module that we use. So I do have to import Unicode data, and I have to import string as well if I want to actually use their functions. So make sure you have Unicode data and also string imported. Great, okay, so that handles that remove accents function. Next up, for each token, we also have to remove punctuation. This is part of the cleaning data phase. So to remove punctuation, I'm going to take my result and I'm going to first convert my result to a string, and then I'm going to translate. So I'm using the translate function with string.punctuation as an argument. Just make sure you spell punctuation correctly. And this is going to strip the punctuation from the result. All right, then I want to have a list of all the tokens that have been processed. So for that, I'm just going to create a list for every single sentence. I'm going to create here a list of sentence tokens. And initially it's going to be an empty array. But then I'm going to append every token in the sentence to that list. So I'll take my list of sentence tokens, and I'm going to use the append function to append my result. As well, I'm going to have another list that is going to check if no lemmetization match can be found. Then I'm going to remove the token. So if I can't tokenize a word, then I'm just going to remove it, because sometimes you will have text or strings that can't be tokenized. So for that, I'm going to make another array, and I'll call this non-lemmetized tokens. So I'm going to create another array here to store the non-lemmetized tokens. And I am going to take that non-lemmetized tokens array, and I'm going to append to it just a hyphen. Then we actually have to process each of the tokens. So I am going to exit, or actually no, I will stay in this loop. And I'm going to check if my result is not in stop words. What is stop words? Okay, we have to define stop words. Let's create a new variable to represent that. Make sure you're outside of your for loop. I'm going to create stop words, and I'm going to use nltk.corpus.stopwords.words English. So that is going to give me all of the English stop words. It's going to be a list. And then we can check if a word is or is not a stop word. Now, in order to actually use nltk.corpus.stopwords, I'm going to call nltk.download stop words. So the NLTK library has many data sets that we can use, including stop words and WordNet, perceptron taggers, and more. All right, so this is going to allow me to check if my result is not a stop word. Then in that case, I'm going to use if re.search revalid, result. Okay, so let's break this down. What is revalid, first of all? Revalid is a constraint on our token that we have to define. So let me just define that. I'm going to define this revalid, and it's going to equal a string A to Z, A to Z. So it means in order for a token to be valid, it has to have English characters, because we're dealing with English data. Now, what is re.search? Well, we have to import as well. It's another module that we need, import re. And it has helper functions such as search. So we're searching that this token is a valid string. All right, and then I'm going to check if the length of my result is greater than or equal to the minimum string length. So I'm going to define that my strings have to have a minimum length to be considered valid. This is another constraint on our tokens. Let's define minimum string length. I'm going to use 3. That's because that will give us a word that can actually be tokenized. All right, and continuing on. Let's say that our token passes all of the constraints. Then I'm going to be able to find the part of speech of that word. So how do we find the part of speech of a word? Let's create here part of speech. We're going to use NLTK again, and we're going to use the part of speech tag. This is going to tag a word by its part of speech, like a noun, verb, adverb, adjective. And so we have to pass in here an array of our result. And as well, we need 0, 1, and up to 2. All right, and the default is going to be a noun. So let me just set here default part of speech is equal to n, which is short for noun. So If we can't find a matching part of speech, then we'll just match it as a noun by default, because that is the most common part of speech. However, if we can find a part of speech with that NLTK library, then we're going to use that instead. All right, continuing on, we're going to check if the part of speech found by NLTK is in our allowed part of speech types. So we're going to create another constant, and it's going to store which part of speech types we allow. So let's create that. And let's just create that again outside of our for loop. Allowed part of speech types. So here's where we can determine the parts of speech that we can allow. So let's create this. This is going to be a dictionary, and we have NN capitalized is going to correspond to a noun. JJ corresponds to an adjective, and we can have a few more. So what we have here is we have a key referring to the NLTK part of speech, and then we have the value referring to how we are going to classify or tag a part of speech. VB is verb, and RB is R, which is adverb. All right, great. So these will be the part of speech types that we allow, because they are the most common ones in English. All right, so if the part of speech found by NLTK is in our allowed part of speech types, we're going to take the default part of speech and assign it to the allowed part of speech types at the current part of speech. So we're using that dictionary to get a value via the key. As well, we're going to get the stem of the word, because every word has a stem. For that, we're going to use stemmer, and we'll use the stem function on the result. So what is stemmer? Stemmer comes from NLTK as well, and we do have to define it at the top of our file. So let's define that. Let's define our stemmer, and we're going to use nltk.stem.porter stemmer. So this is one instance of a stemmer type from NLTK, the porter stemmer. Okay, and we do have to define that if we want to actually use the porter stemmer's functions. All right, and that is going to return for us the stem of the result, or the token. And it's going to do that for us with the library. So as you can start to see, the NLTK library is very useful for doing natural language processing really quickly. Otherwise, we'd have to do all this from scratch, and that's a lot of math and machine learning, or data science rather. Okay, next, we also are going to lemmetize the word with its correct part of speech. So I'm going to create here lemmetization, and I'm going to use a lemmetizer.lemmetize. So we're going to create a lemmetizer and use its lemmetize function. We pass in the result, or what is to be lemmetized. We also have to pass in an argument known as POS, or part of speech. And this is going to equal our default part of speech. Okay, let's define that lemmetizer, because we can't actually use it unless we have it defined. So it comes from NLTK again. I'm going to define this lemmetizer variable and use nltk.stem again, and I'm using the word net lemmetizer. Okay, great. That will allow us access to the functions of word net lemmetizer, including just the lemmetize function, which takes in what you want to lemmetize, and it also takes in the part of speech. All right, next we're going to check here if part of speech is in our part of speech types. So I'm going to create part of speech types. Okay, what is part of speech types? Well, this is going to be just a list of all of the keys in our allowed part of speech types. So let me call this part of speech types keys. Now let's define that part of speech types types keys. And I'm going to define that just below where we defined allowed part of speech types. And what I'm going to do is use the list function to convert allowed part of speech types, and I'm going to convert its keys to a list. So what you can do is just take a dictionary, get its keys with the keys function, and then just convert that to a list. That's what we're doing here. And that will return for us part of speech types keys. All right, so I have all the keys now. And what I'm going to do is I am going to create a new appending into my list of all of my tokens. So I'm going to create another list here, and I'm just going to make sure that it's outside of my enumerating for loop. So outside of my entire for loop, I'm going to create here my tokens list, okay? And it's going to be this empty array initially. But then for every token that I find, I am going to add it to that list of tokens. So I'll take my tokens list and I'll append to it. Make sure you have double parentheses here because we're appending an entry. I'm appending my result with my stem, my lemmetization, and my part of speech. All right, so that is going to mean that our token, each token in the tokens list is going to be this entry of result, stem, lemmetization, and part of speech, which means for every word, we're going to have those 4 different values. We also have to remove that non-lemmetized token, that hyphen, and we have to instead append the lemmetization match. So what I will do is access that list that I created earlier of my non-lemmetized list. Okay, it was called here non-lemmetized tokens. So I want to take that and I am going to assign it to equal itself up to -1. So I'm just removing it, and then I'm going to take it and append to it my lemmetization. So we have to take the non-lemmetized and append the lemmetization match. All right, and now I want to build a list of my token lists, and I'm going to do that outside of my for loop once I have all of my tokens. So just hit enter and make sure that you are outside of the for loop, because in Python indentation matters. Okay, great. So we're going to be just making sure that we are outside of that nested for loop, but that you're still inside of this overall one. Okay, so make sure you only have one indentation then. And I'm going to take my tokens list, and I need to then create a list of all of these tokens lists. So I'll just create all tokens list, and I'm going to append to it my tokens list that I had earlier, and that was when I appended it. So let's see, that would be right here, my list of sentence tokens. So I need to take that and I need to append it to all of my tokens lists. And I do have to define this all tokens list because currently we are only assigning to it, but we haven't actually created it. So just make sure that you do create it. Let's see, where should we create this? Let's just create it outside of that for loop, all tokens lists. And it's going to be an array, empty initially, but then for every single sentence, we're just going to add to this all tokens lists, this sentence tokenized. As well, I want to also build a list of strings from my lemmetized tokens. So I'm going to create here lemmetized list, lemmetized tokens list. And I am going to assign it to equal an empty, just a space, joined with my non-lemmetized tokens. So this non-lemmetized tokens, it was initially non-lemmetized, but then at the very end, we do actually lemmetize it. So we have to then add it to the lemmetized tokens list. All right. And as well, I'm going to then keep track of all of my lemmetized tokens. So I'm going to create all lemmetized tokens here. And I'm going to append to it my lemmetized tokens list. All right, and then we do have to define that all lemmetized tokens. Let's define that just outside of that larger for loop. So now we have our tokens list, our all tokens lists, and our all lemmatized tokens. All right, great. So it's a lot of lists to keep track of, but just as long as you have naming all properly set up and that you don't accidentally enter the wrong name, then you'll be just fine. Okay, and just like that, we have looped through all of our sentences and we've tokenized all of the words and all the sentences. And we can build a data frame from all those lists. So I'm going to create my data frame tokens and I'm going to use pandas.dataframe. So here I'm actually instantiating a new data frame object and I'm creating a data frame out of all tokens lists. So that will give me a data frame of all of my sentences and words tokenized. All right, then we can print out our result. I'm going to print out here my data frame tokens, and I'll run this code cell. We're going to get the result of all of our values. Okay, let's see. Okay, we do have to also download the PUNKT, the punct module, just to perform the sent tokenize and the word tokenize. So let's just import that at the top of our file. So we have imported NLTK. We just need to also download here, nltk.download punkt punct. Okay, and then I can just rerun that code cell once I have that module downloaded. Okay, let's see what else we need here. Okay, we also have invalid normalization form. So let me just make sure we have here. Oh, why did I type in NKFD? Let's see what we actually need here instead of we need NFKD. Yes, okay. Make sure that your normalization type is NFKD. Okay, we also do have to import average perceptron tagger. So let me just import that, or download it rather, nltk.download my averaged perceptron tagger. We also need that in order to tag the part of speech. So let me just rerun this code cell again. I think we need one more thing downloaded as well. Let's see. Yes, we also need to download a WordNet. So working with NLTK, you have to download these specific modules that you want. I need WordNet. The reason is that NLTK is actually huge. It's a very huge library, so we don't actually download all of it at once. That would take a long time. We just download what we need. So we download stop words, punct, averaged, perceptron tagger, and WordNet. I didn't want to just download all of NLTK at once because it would take a while. Instead, we just download what we need. It also saves memory. Okay, great. So once we've downloaded all those four, then we'll get this result. Okay, look at that. So look at what we get. First, we download all the required packages, and then we get this list of columns. So we have indices 0 to 28, and we have different words at each column. And that is our data frame tokens that we've just created. Okay, and you can see that some of the columns actually have the value of none. So we can actually remove that as well. I can show you how to remove that. I want to also convert it to a string, so let me just print out here. Let's print out our data frame. Let's see, what did we call this? Data frame tokens. Let's print out data frame tokens dot head dot to string. So I'm going to convert it to a string this time, and look, it's just a bit easier to read. So we have the different words in our sentences, okay? And every word here has its own column because every word has been tokenized, and then the sentence has been tokenized as well. So there can never be too many cherries on an ice cream sundae. There's a message for you if you look up. He liked to play with words in the bathtub. So you can see each of these words has been separated, but the sentence is still there. It's just been tokenized. And we also have these none values because sometimes sentences are not that long. So we can see that a sentence can go up to 28 words in length here in this tokenization. All right, awesome. And that is how you can tokenize your sentences and also individual words in each sentence. Coming up, we are going to learn how we can further process our results. So we're going to remove any none values. We're also going to learn how we can find the most popular words and the most popular parts of speech and more. So join me in the next lecture where we are going to continue our project.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.